Good day, everyone, and welcome to Math tutorial brought to you by Expert Education Center. My name is Peter Ohwe. Last time, we defined a set, we looked at the subsets, and then the term complement of a set. Today, we are moving a step ahead, and we shall be looking at the union and the intersection of sets. The union of two or more sets can be defined as that set that contains elements derived from combining the sets. For example, given that the universal set mu contains elements x such that -3 is less than or equal to x, which is less than 5, p is equal to the set of x greater than 2, and q is the set x such that -1 is less than or equal to x, less than or equal to 3. Then the union of P and Q, written as PUQ, will be derived as we see below. The universal set again is the set of numbers from -3 to 4. We are not including 5 because the equality sign is not before the number 5, as seen in line 3 above. P, on the other hand, is the set containing elements 3 and 4. Since P is a subset of the universal set, we are not allowed to go beyond the limits of the universal set. Q, on the other hand, contains elements from -1 to 3, including -1 and 3. Compare the inequality signs in Q and inequality signs in the universal set. Therefore, the union of P and Q, written as PUQ, will be the set containing elements -1, 0, 1, 2, 3, 3 again, and 4. Notice that a set contains distinct elements. Therefore, the other 3 will be removed. P union Q is hence equal to -1, 0, 1, 2, 3, and 4. The intersection of two or more sets is the set that contains elements common to all the subsets. Take note of the word common. It is important that the intersection has the elements that are found in every set that is to be joined to others. For example, if the universal set contains the elements 0, 1, 2, 3, 4, 5, 6, 7, and set A contains 2, 4, 6, 7, B has 1, 2, 4, 5, and C has 0, 4, 6, 7. We can go ahead and find the following set. We can find A intersection B, A intersection C, and also A intersection B intersection C. For A intersection, we look out for the elements in A and the elements in B. Then we compare the two sets to see if they have elements in common. When we do this, we realize that 2 and 4 are elements that are common to both sets. Therefore, 2 and 4 are the elements of A intersection B. For question 2, A intersection C is the set that contains elements common to A and C. And as shown with the red ink, 4 and 6 are elements found in A and at the same time found in B. In question 3, we are looking out for elements found in A at the same time in B and also in C. And when we carefully compare these 3 subsets, we realize that the only element that is found in all 3 sets at the same time is the number 4. Last time, we talked about the cardinality of a set. We described it as the number of elements found in a set. We can go ahead and determine the cardinality of the 3 examples that we have seen above. In number 1, we discovered that the elements in A intersection B were 2 and 4. Therefore, the cardinality of A intersection B is 2. In the same way, the cardinality of A intersection C is 2, while the intersection of A, B, and C is 1, because it contains just one element. One fantastic way of representing set is by making use of diagrams. And a very good example is the Venn diagram. A Venn diagram is a picture representing a set with a rectangle that represents the universal set, and a circle in the case of one subset, and 2 or more depending on the number of subsets. Let's begin by considering a universal set that has one subset. The rectangle colored green is a universal set, while the circle blue is the subset A. A contains 2 elements, and there are 2 elements that are outside A. In essence, the universal set will contain elements 1, 2, 3, and 4, because they are all found in the rectangle. The set A will contain elements 1 and 3 in the blue portion. While A complement, which we described last time as a complement containing elements that are not in A. If you take out 1 and 3, you'll be left with 2 and 4. So we say A complement, also written as A raised to power C or A prime, is a set that contains elements not found in A, but found in the universal set. Hence, our values are 2 and 4. We move on to consider a Venn diagram that has 2 subsets, A and B. 2 subsets, 2 circles. Notice that these 2 subsets overlap. They are joined. They have something in common. It is possible to have sets that do not have elements in common. Such are described as disjoint sets that are not joined. But this example gives us an opportunity to look at intersection of sets and the union of sets. From the diagram, we can clearly see that every element is found in the rectangle. Therefore, the elements in the universal set will be 1, 2, 3, 4, up to 10. But for elements in A, we are going to focus on the numbers written with blue ink because they are found inside the circle that represents A. We have taken away the set B for the purpose of making this very clear. On the other hand, the elements in B are the elements that are contained in the circle B, and the yellow ink helps us to identify them. These elements are 2, 3, 4, 6, 7, and 8. The elements in A complement, that is elements that are not in the set A, but are in the universal set, are all written in blue ink, and they are 1, 2, 6, 4, 8, and 9. Note that it is important that elements do not repeat themselves and that they are arranged in the proper order. So A complement will be 1, 2, 4, 6, 8, and 9. The elements in B complement are elements that are outside the circle B. And these elements are 1, 5, 9, and 10. To the real business, we are focusing on A union B. And if you check our Venn diagram, you will realize that some elements have been taken off. The numbers 1 and 9, which hitherto were outside the 2 circles. Therefore, A union B, which is an aggregate of A and B, will produce a set 2, 3, 4, 5, 6, 7, 8, and 10. On the other hand, A intersection B is that set that contains elements common to A and B. And using this Venn diagram, we realize that 3 and 7 written boldly are the elements found in the set A intersection B. Then A intersection B complement, which we can define as elements in the set A but are not in the set B. So we are describing elements in A only, and our result will be 5 and 10. A complement intersection B will represent the set that contains elements found in B but are not found in the set A. Here we have 2, 4, 6, and 8. Finally, A complement intersection B complement are elements that are not in A and at the same time are not in B. Those elements are outside the circles but inside the rectangle. These elements are 1 and 9. Thank you for watching. Please drop a comment below and subscribe to our channel. God bless.